Today we are here at 4M to learn more about adhesives and what they are, how they're made, and how they work. Today we have several representatives from 4M to talk more about adhesives with us. This is Cassandra, a 20-year industry expert in the adhesive business. They've stuck to this field for a long time and would love to talk about the history of glue.
Hi, my name is Cassandra. I'm a scientist here at 4M. Glues or adhesives have been put to work by humans for thousands of years. Most primitive glues were natural adhesives relying on stickiness and viscosity of a substance rather than any reactive adhesive effects. Some traditional natural adhesives include tar, sap, and beeswax. Nowadays, adhesives are more industrially produced, relying on the chemical properties of different substances in order to bond items together. We will see some of our factory workers and some of our other scientists really put this chemistry to use and learn a little bit more about adhesives. Thank you, Nina, and I'll pass it back to you.
Thank you, Cassandra, for introducing us to the fascinating history of adhesives. Now that we've bonded together on how adhesives were discovered and used back in the day, you might be wondering what counts as an adhesive and how do these adhesives work? To learn more about different types of adhesives, let's speak to another 4M representative. Now, I'd like to introduce Aneesh, a longtime expert in the adhesive industry. His research sticks to the classifications of adhesives, mainly the differences between natural and synthetic adhesives.
Thanks for having me on the show. It's always a pleasure to talk to you about glue. Like Nina said, my work focuses on classifying natural and synthetic adhesives. One of the most basic examples of natural adhesives is hide glue. Hide glue is made by soaking the hide in water and treating it with lime to break down impurities. The hide is then rinsed off with water and neutralized with a weak acid. Finally, the hide is heated in water to just below boiling temperature, and the stock produced is cooled to form glue. Collagen is primarily responsible for the adhesive properties of hide glue. Collagen is a protein that forms the extracellular matrix of animal connective tissues and consists of amino acids linked by peptide bonds. The amino acid polymer chains form hydrogen bonds with each other, resulting in strong adhesive forces. However, animal glues are susceptible to moisture and microbial contamination, so they are not widely used.
Wow, I had no idea how interesting natural adhesives were and how they're produced from natural products. Thank you, Aneesh. Now, I recall you mentioned in the beginning that there are two types of adhesives, and we just spoke together about the first type, natural adhesives. Could you tell us a little more about synthetic adhesives?
Yeah, of course. Synthetic adhesives are generally polymers derived from petrochemicals. Synthetic adhesives were originally needed for high structural strength and resistance to more extreme environments, but now synthetic adhesives can be found everywhere. Synthetic glues can be broken down into two types, thermoplastics and thermosets. The difference between these two types lies in the heating process. Thermoplastics can be reheated, cooled, and reshaped. Thermosets undergo curing, which leads to irreversible chemical changes that lock in the shape in exchange for stronger bonding. One of the most common thermoplastic adhesives is cyanoacrylate, which is the primary ingredient of commercial superglues. Ethyl 2-cyanoacrylate consists of a nitrile, alkene, and ethyl ester with the formula C6H7NO2. Repeated monomers of cyanoacrylate form superglue.
Thank you, Aneesh, for teaching us about natural and synthetic adhesives and providing us with some examples. After learning about certain types of adhesives, you must be wondering how these adhesives are produced. Let's take an exclusive look inside one of the manufacturing plants here at 4M. I'm here with Adam, an expert on epoxy resin synthesis and polymerization.
Hi, Nina. Here at 4M, we produce hundreds of different adhesives, each with their own unique production process and synthesis. Today, I'm outside just one of our many manufacturing plants across the world, and at this one in particular, we synthesize bisphenol A diglycidyl ether, or BADG for short, an epoxy resin with a wide range of applications from aerospace and material science to semiconductor manufacturing. Let me take you guys inside so we can delve a little bit deeper into some of the amazing chemistry that takes place here at this facility.
Now that we're inside, let me tell you a little bit more about the synthesis of epoxy. So BADG is a thermoset plastic made by reacting epichlorohydrin with bisphenol A. Sodium hydroxide is also added to remove the unnecessary chlorine and hydrogen atoms from the intermediate complex, completing the epoxide ring. However, this reaction produces badge as a monomer, which at room temperature is a liquid and can be a little bit difficult to use as an adhesive. To produce a solid and more malleable resin, we use a process called pre-polymerization. Pre-polymerization is a process by which a monomer reacts with itself to form a pre-polymer. For badge, this process begins with liquid badge and some additional bisphenol A. We then heat the reaction vessel to around 150 Celsius or 320 Fahrenheit, allowing the bisphenol A's to react with the badge to form a chain of bisphenol A's terminated by 2 epoxide groups. Once pre-polymerized, the linked badge complex can be reacted with a substance called a hardener or a curative to start a further polymerization reaction that reveals badge's durability, versatility, and adhesive properties. And while both are polymerization reactions, the curing reaction occurs in a slightly different way chemically than the pre-polymerization reaction. A diamine is a good example of a curative that reacts well with badge. The nitrogens from the diamine will attack the carbons on badge's epoxide groups, forming a secondary amine. Now what's interesting about this reaction, and what makes the badge-diamine reaction such a good polymerization reaction, is that each diamine molecule can react with 4 different badge molecules. The reason for this is that the diamines have 2 nitrogens. Further, after each nitrogen reacts with 1 badge molecule, yet another lone pair is present and can react with yet another badge molecule. On the screen, you'll see a fully polymerized badge-diamine complex. Thanks for having me on, Nina.
Thank you, Adam, for an in-depth look behind the scenes here at 4M to show us how their adhesives are made. We've learned a lot so far about certain types of adhesives and their properties in the production process. I'm back here with Cassandra to ask another question that's been stuck in my mind. Cassandra, there's such a wide variety of adhesives here at 4M. How do I know what's the best adhesive to pick?
Hello Nina, I'm glad to be back and tell you a little bit more about the pros and cons of different adhesive types and which will be suitable for your needs. If you go into your local convenience store, you may see that there are a wide variety of adhesive products available to consumers. This is mainly due to the fact that many adhesives may work well on one material, but not as well on other materials. For example, you wouldn't want to purchase a cyanoacrylate adhesive for your child to take to school for their arts and crafts project. Instead, you'd probably want to purchase a PVA-based adhesive commonly found in glue sticks. Cyanoacrylate takes advantage of the moisture in the air to hydrolyze the C-N bond, forming free ions that will then react with other monomers to polymerize and harden at the surface. This makes cyanoacrylate water resistant to a certain degree, of course. On the other hand, polyvinyl acetate, or PVA, is a water-soluble adhesive that will readily dissociate when exposed to moisture. This is because there is a hydroxyl group on the monomer that will hydrogen bond with H2O, breaking down the molecule. Clearly, PVA would be the better option for use by a small child because if it ends up on their desk or all over their hands, it can be easily washed off.
Thank you to 4M and their brilliant scientists and workers for providing us an exclusive interview on adhesives. Today, we bonded together on the history of adhesives, the different classifications of adhesives, how they're made, and the pros and cons of adhesives to help us the next time we're stuck in the store trying to figure out which glue to buy. I bet you're all feeling pretty attached to the world of adhesives right now, but we can't stick around any longer because that's all the time we have for today. Have a good day.